Dear student, this is the question of the analog electronics, and they have provided the circuit with BJT, and they have provided one data. That means the data is common base gain. That means alpha is about to unity. That means the value of the beta is very high, very high. That means whenever you will get the beta in your calculations, you have to assume the beta value is very high. That means for calculating the bias point, we have to calculate the Thevenin equivalent seen from here. As you will do the Thevenin equivalent calculation, that means the VTH across this you have to calculate. That means the voltage across the 16 with respect to 18. That means 16 plus 44. This will be in K, and K will cancel out here. 16 into 18 divided by 60. Here 10, 3. That means the 4.8 volts. You will get VTH. The value of RTH will be 16K parallel with 44K. That means your modified circuit will look like this. Your modified circuit will look like this. This is the RTH and this is the value of VTH. Now, just apply the KVL at this side. Apply the KCL, and the value of the I of B will be VTH minus 0.7 divided by RTH plus 1 plus beta into 2 of K. Here I have assumed the value of this potential VB is 0.7, and I have assumed this is in active region. That means your value will be like this, and they have provided the beta value is very high. That means you can assume like this. VTH value is 4.8 minus 0.7 divided by. This value is very high with respect to this. That means you can write down like this, 1 plus beta into 2 of K. But if beta is very high, that means you can neglect this one also, like this. And here you will get 4.1 divided by 2 of K into beta. Yes, this is the value of I of B. Now, if I of C I want to calculate beta into I of B, that means the 4.1 divided by 2K into beta. Beta will cancel out, and you will get 2.05. That means the total value is 2.05 milliampere. That means I have assumed my transistor is in active region. That means the IC I got, the value of IC in active is 2.05 milliampere. And then we will check whether this is in active or not. It may be in saturation also. That means we have to check that also, otherwise we will do the mistake. If we are getting active, that will be okay, but whenever you are doing the exam, you don't know whether that is in active or saturation. You have to check. I am assuming if this will be in saturation, VC should be 0.2. That means I will calculate the value of I of C. If that I of C is greater than this, that means in active region. If that is less than this, that means in saturation region. That means 18 minus 0.2 divided by 4 plus 2. And here one more thing, IC is about equal to I of E. We have this freedom just because of this data. That means the value of I of C is given by 6 of K. That means 17.8 divided by 6 of K. Definitely this value will be greater than this. That means our previous assumption is very right. That means this transistor is in active region. That means this IC is flowing actually in the circuit. That means whenever you will calculate this, if this is not saturation, you don't know this value. That means you have to assume the value is VCE. Just apply the KVL in this path and you will get the VCE will be 18 minus 6K total resistance into total current into 2.05 milliampere. This milli and kilo will cancel out. 18 minus 12.3, and here you will get 5.7 volts VCE, and this is your right answer.